Hi guys, good afternoon. I'm going to take the next 20 minutes to talk about building a cloud native platform. Hi everybody in the crowd. I work in the high-tech industry for over 20 years as a consultant, and the last 15 years mostly came from operations. And what happened in the last 10 years, more or less, then I moved from the operations chair to a developer's chair. And I found myself asking a lot of questions of how to actually develop software and not only operate it. And I'm going to talk about two principles today. Luckily, I come from a consulting firm, and this isn't working. Okay. Luckily, I come from a consulting firm, and we have teams in back-end, front-end, mobile, machine learning, and front-end, if I didn't say. Of course, DevOps is one of the teams that I represent. And again, because I'm surrounded by experts, so I think I have the ability to talk about building an application brick by brick. And some of you may ask yourself why this word platform was just stroke out, because you will eventually build a platform around your application. What I want to focus on today is something really happened in the last 20 years. Like everything is in the cloud and everything is data driven, and there's so many things that are happening, and we actually looked for solutions for those type of architectures that we chose to build our application around. And we see serverless, we see microservices, we see a lot of architectures which I think in the long term will be a good investment, but in the short term make us, like we say in Hebrew, balagan, a lot of balagan. And every company that I move into uses a blend of these architectures. It isn't only one architecture which fits everything. The only thing that everybody agrees upon is not the architecture, it's the fact that the cost of developing that it needs to be better than the bottom line. We can't continue building software and paying so much for maintenance. And that is something that happens a lot, at least I see it. So with that problem, how do you actually go about building a cloud native application? And when I say cloud native, how does it actually run in the cloud, and how is it portable? And when I started 20 years ago, I remember they used to say, write once, run anywhere, about Java, right? And we learned that that isn't the case. And today, if we want to write software which will run any cloud, that still isn't the case, at least from my perspective. Now, there's something that everyone agrees upon. You usually start a new project with Git, or even if you start building a team around an application which you wrote as a startup, everybody knows how to work with that tool. Probably, if not, the rest of this talk isn't for you. And it really doesn't matter what architectural style you use. There's a lot of options there when you start building your application. And if it's a startup, you might be running or building a great big monolith. And eventually, when you get your first investment, you might start to breaking it down. And I think we're at Walmart here, which I was surprised we're still building a monolith. It's still around the data platform. But anyway, it doesn't matter really what architecture you choose. You want to follow these two principles. One of them, has anybody heard of 12-factor app principle? A relatively small number, and I'm very surprised. And I'm sure that who heard of the Cloud Native Foundation landscape? That makes sense. So what I'm going to talk about in the next, 16 minutes, which I have left, so I'm going to speed up my talk a bit. I'm going to talk about how we actually implement these changes. And the 12-factor app principles, whoever isn't familiar with, I'm going to skip some of them. I'm going to talk about nine of them, more or less. Was actually developed for building a platform as a service. And if everybody here is building an application, he's eventually building a platform for the engineers developing it. Because I have to provide a lot of services to my developers for them to be able to do their job. This is where the cloud native landscape comes in. The cloud native landscape was built or sprung out of the Linux Foundation, and it came to provide solutions for anything containerized, anything in a container, and that doesn't necessarily mean Docker, but Docker, I think, used to be dominant there. Today we have Containerd or other technologies. When Adam Higgins built Heroku, I don't know if you remember We call it the nice days of Ruby on Rails when everything was, one binary which did everything. It wasn't relatively ready even for microservices, but it had a lot of principles which helped build this platform, which was called Heroku. And if you recall, Heroku had this CLI, which you could say Heroku app or whatever, very similar to the way we work with kubectl today, and actually get a lot of things done, or gcloud API, or whatever CLIs you're using. I want to start with config, which is, I think, is the third principle in the 12-factor app, and we can see how the cloud-native foundation, and mostly dominant is Kubernetes, is we moved from building packs of software with their own kind of lifecycle to a declarative way of I want this to happen, and just telling the cloud or the platform that I'm using what I actually want to get out of it. The second principle, or the fourth principle actually for the 12-factor app, is backing services. We actually decouple the application. We said that on microservice, if it needs to store any data, you should do it on a detached service like any backend, for example, a cache, a queue, a database. And that means that when I actually want to restart my application, that doesn't mean that I'm restarting my database or I'm doing anything changes to my database. It needs to be decoupled from the application. Its only purpose is to actually serve the app, so there's no reason to actually keep it up and running. One of the things that this principle gave us is the fact that we're not going to keep anything local in our application. There's no caching, there's no data, there's maybe a temp folder, but that means that if I restart the application, I can still recover without losing any of the data. The Cloud Native Foundation has a vast line of solutions. For example, for streaming, I just took a few examples in each slide. For example, for using Kafka, there's a solution by Streamzy, which is a solution to actually run Kafka servers. Kafka as a service on your cluster. Or Vitas, which is running databases, very similar to how you would run RDS. So think about the fact that you don't need to actually take care of building your database. There is a ready-made solution out there. You just need to install it. And as we will see with the Cloud Native, everything is like a Helm install something. And Helm install this solution will probably provide you a solution for running your databases. This fact alone makes you cloud portable, because I can actually change or move the application and leaving the database in a separate place. For example, I can run an RDS, okay, which will store my data, but run the workload on GCP, for example, just to do that transition. So it's not an easy task to do, but this fact alone makes you cloud native, makes you cloud portable, actually. CI/CD, today any cloud provider will go to, there's already a solution to build your application, to store the containers. And this is, I was thinking of skipping this one, but every cloud provider has it, and GitHub or GitLab or all the providers of source control have that right near their service. Processes, and I think this one is the most important one. And considering the fact that the Cloud Native Foundation was built out of Linux, Linux has a design which shows us to do one thing and one thing great, and microservices are the same thing. If we start putting a lot of processes inside a container, we're surely going to fail. So one of the key principles is to keep them very small and lightweight, so I don't actually need to manage multiple services, and this alone has another impact on a lot of things, which I'll get to in a sec. Yes, you can run a monolith, but the monolith will usually make you go through a lot of stack traces and so on. And this is where you have to start thinking about the architecture style you want to use. And this is where, what I said before, it doesn't matter what kind of architecture you would use, you might want to use microservices because of these principles, because of the fact that they're portable, because of the fact that it's much easier to maintain and understand what they actually did. And also, it's easy to rewrite because it's a very small app which I can actually replace whenever I want. That was the idea behind it. If we look at the Kubernetes architecture, which is the core functionality around the Cloud Native Foundation, we see Kubernetes, and whoever is familiar with Kubernetes, Kubernetes is built as a microservices architecture. There's controllers, there's a control loop, which actually makes sure that my processes are up and running. There's a key value store, which stores all the information about our application. So basically, the architecture itself is built on the 12-factor app principles, and we should want to use it. And this kubectl, this part alone, this command line, which I also mentioned about Heroku, is a core part of Kubernetes. Has anyone run with Kubernetes without using kubectl? And what's up? There's no way. So really what we're saying is this influence that the 12-factor app had on the Cloud Native Foundation and on all the projects we will see there, and there's a graduation part, whoever's familiar with the Cloud Native itself, which also influenced the way we consume services. Managed services used to be a foul word. Today, every application uses a managed service, either a managed Kubernetes on one of the clouds, either an RDS or a cloud SQL, some kind of service or a queue or whatever else which is outside, not part of my application, not something that I need to own. One of the principles that happened to us because everything is in the cloud is port binding. Think about this. In the past, we used to run on a single machine, and we used to have this socket we could write and read from. Today, everything is in the cloud. I'm not sure where it's running. It's running in a pod on a machine, so if I don't bind it to a port, there's no way for me to communicate with the service. This is where actually our services are listening on, so I can actually communicate with them. This pattern, if we look at, again, Kubernetes, liveness and readiness probes are a core part of how we actually provide a rolling update. The service mesh that we all talked about, Istio and all these kind of solutions, without being able to communicate with our services via a live port, it wouldn't be viable. All these principles so far has enabled us actually to be concurrent. We can actually run more and more instances of a specific service without going down, because the database is detached, there's no local storage, the configuration is declarative, so it's very easy for me to have more than one service or more than one instance of my application. This opened a broad landscape like canary releases, something we could do before, but was very, very hard to accomplish. Another thing is concurrency, declarativity, and all kinds of architecture styles like shared state. All of these are now a capability we can actually do, and this is where the Cloud Native Foundation gave us stateful sets, the ability to have highly available applications and decoupling the data from the nodes we're running on. I'm not sure how many of you are running Kubernetes in production, but attaching or detaching a volume from AWS or from Google to my workload is something that we do repeatedly all the time. Disposability. This principle means I can actually restart my application without hurting my customer, my consumer. And the fact that I have concurrency and detached services and declarative configuration, that means I can just say, give me one more instance of this workload, and that's it. Or providing or running a rolling update will ensure that first of all, I'll have a new set up, and only then I can route traffic to it, and then decommissioning the old one. So these principles are things you want to adhere to in a cloud native landscape. So who's working with Kubernetes here? Who doesn't know what a replica set is? Get out of here, I'm joking. But a replica set is really only of that principle alone, because everything is outside and managed outside, not outside, but everything is managed outside of my application. I don't need to take care of these capabilities, and this is what gives me features like deployment, daemon sets, and other deployment styles, which are highly available and, of course, scalable. Because everything is declarative, I will not have two environments which aren't similar. So really, and one of the things that used to be very common, and I worked as a configuration manager for, like I said, almost 2 decades in the industry, and I've seen where in development there's no cache, but in production there is a cache. So actually what happens when I deploy to production, I'm actually testing or using a feature I haven't been doing in development. This is something that, because the Cloud Native Foundation provides us tooling to actually run things on our local cluster, which could be running on our machine by K3D or Minikube or whatever you want to choose it, it would be the same kind of components you would run in production. Maybe the RDS would be a MySQL version of Amazon, but the MySQL I run in the cluster would be some kind of held by Bitnami, but it will be the same kind of components. I don't want to have a different stack when I'm developing or testing or running in production. And again, there's a broad solution based here, specifically when we're looking at things like GitOps, Argo CD, or Flux CD, which actually sync our application. So we will have our dev environment there, we'll have our staging environment, we'll have our production environment, and so on. And this is the way that we can actually start testing our application because they're very similar to the environment we're running in production. Who does logging? Who uses Log4j? Who forwards their log to Logs.io or CoreLogix or something like that? So this is a great example of what the Cloud Native Foundation did for us again. Because in the past, we used to write logs, or we used to write a logger, and when you looked at the log, it was this long stack trace, and you had to start, letayel, how do you say, to start walking on the stack trace stuff of the logs, and it was a very hard time to understand. Because we're microservices, everything is small, so think of event streams. Everything is an event that happened. Someone used my application, therefore there is a log which says something very meaningful to me. So the approach of, first of all, how logs look like is much simpler when you're doing single processing. You're doing a very small process, a very simple process, so you don't need to ask, what does this log mean for application which is called users, or give them, of course, meaningful names. At this point, I'll tell you, if you look at after this meeting, whoever didn't hear about the landscape of the Cloud Native landscape is welcome to actually start looking it up. There's an entire application, like a small web application, which provides solutions for logging, for installing, for anything else really related to running microservices. Admin processes. Because I mentioned before Ruby on Rails, whoever recalls, there was this command called db migrate. Managing your database schema is part of managing your application. And if every application has a detached backend, so maybe every application has its own schema, which it needs to take care of. Very simple principle that I actually need to do throughout my application. Kubernetes, in the core, again, behind the scenes, has an ability to run an init container or a sidecar container to serve my application. There's no reason to take 2 gigabytes of RAM to run my big Java application if the DB init script didn't finish. There's just no reason to waste that amount of compute. So this is a small pattern which also helps us to be more cost effective. Beyond the 12-factor principles, and this is basically because Heroku or the 12-factor wasn't written, it was written for web services, but wasn't written for containers. So there's 3 more principles, which is also a great book by O'Reilly called Beyond the 12-Factor App, which I recommend you read, which talks about 3 more principles. One of them is API first. And whoever is familiar with OpenAPI, anybody worked with OpenAPI? Great. It's a very easy way of telling everyone that onboarding to my company or coming in to my team how to actually work, how to write APIs, how to document them, and so on. Just pick a standard. It doesn't matter if it's this one or another, but API first means that everybody really knows how to actually contribute to your project. Because we're running in the cloud, and I'm speeding up a bit because I have 1 minute left, so telemetry is something that we have to start doing because of the fact that we're not running on one machine. We're running on a number of machines in a cluster, so it's not enough to look on the performance of one machine. We actually need a lot of KPIs to actually collect those. OTel, or OpenTelemetry, is a great project of doing that, which actually scales the solution itself. It has an agent which will run on your machine and send everything that it collects to a centralized database, and then you can start making insights out of those. The last one is authentication and authorization. The fact that we're running in the cloud, for example, if I'm an app which needs to write and read from S3, so I need a role which is not only for my application, it's also for the cloud provider, so that makes it very hard to manage but unless I know how to actually do it. So IRSA or web identity are two ways of doing that. Thank you very much.